Hello, everyone. Mr. Minnick's my name. Math is my game. Today, we're joined by my second period Algebra II class. They're excited to be here. All right. So it's the 26th of September, 8:52 in the morning. Here we are, Chapter 3, Section 1. The title is Solve Systems Using Graphs and Tables. Solve systems using graphs and tables. A lot of information in here. A lot of the information in here will be on Friday's quiz over this material. Remember, Friday's quiz is open note, but not calculator. So solve systems using graphs and tables. Probably the first thing we ought to define is what a system is. I wouldn't take notes on the next 25 seconds. A lot of people make a mistake and they think this is a system. They put two 12s in their trunk with like a 1,000,000-watt amp, and they hook it up and they drive through your neighborhood at 2 in the morning and they go, That's not a system, okay? That's having some bass in your trunk. That's not a system. A system is comprised of much more than that. But anyway, that's another story. Okay, so here's what I'd write down. A system of equations. A system of equations is a set of not one, but two or more equations. Two or more equations using the same variables. Okay. So we're going to have one equation with some x's and y's in it. We'll have another equation with some x's and y's in it. That's what a system of equations is. System of equations is a set of two or more equations using the same variables. Okay. Now we are going to be solving these in this section. So guess what the next definition should probably be? What is a solution of a system? So there's actually two definitions to a solution to a system. Graphically, I'll say graphically, comma, the solution to a system of equations is the point where the graphs meet. Is the point where the graphs meet. A lot of writing today. My arm's going to be sore. So graphically speaking, the solution to a system of equations is the point. Oh, having trouble with the smartboard today. Is the point, that should say where, not when. Is the point where the graphs meet. The point where the graphs meet. And this should be 3.1, not 3.9. Okay. So graphically, the solution to a system of equations is the point where the graphs meet. Can anybody think of what might happen if we had some lines whose slope was the same with different y-intercepts? What would happen with those lines? Those lines wouldn't meet. And we'll be talking about that in a minute. Okay, so that's graphically, that's what the solution is. There is one more definition that I want you to have in your notes. Algebraically, comma, the solution to a system of equations is the solution to a system of equations is the ordered pair that satisfies. When I say satisfies, I'm not talking about Snickers. I'm talking about makes true That's what satisfies means in this context. Algebraically, the solution to a system of equations is the ordered pair that satisfies both equations. Sometimes you might get an ordered pair or a point, if you would, that makes one of the equations true, but it's got to satisfy both equations. So algebraically, the solution to a system of equations is the ordered pair that satisfies both equations. Regardless of what type of answer we're talking about, we ought to write our answers, if there is one, solutions should be written. Solutions should be written whenever possible. So I'm going to put that in parentheses. When possible, solutions should be written as ordered pairs, as an ordered pair. So on Friday's quiz, one of the questions might say, explain what the solution to a system of equations is, and be sure to discuss how solutions should be written. Solutions should be written as an ordered pair, whenever possible. Okay. Solutions should be written whenever possible as an ordered pair. That's the bulk of the writing. There's 3 different classifications we'll need to see. We've got a few examples coming up. So that's that. How we feeling so far? Fresh? Dressed? Like $1 million bucks? It's a Monday. It's an early Monday. Here we go. Example numero uno. Example 1. Solve by using tables. I like to get the tables one out of the way. I'll be honest with you. I'm not a fan of the table method. Can't stand it. Don't like it. One bit. So remember, we said a system is a set. So here's that thing, the brace, because that's what we use to enclose sets. So my one equation is going to be that y, and I'm going to call it y sub 1. Hopefully that doesn't mess you up. Y sub 1. That's my first equation, first of 2, is x plus 5. And my second equation, I'm going to call it y sub 2. So our second equation here, y sub 2, is going to be given by negative 2x minus 4. Okay. So I'm going to make a table a little bit different than you're used to seeing. Most of you have seen tables with 2 columns, x and y. I'm going to put 3 columns on my table. And rather than writing y, because I know it's y, I'm going to write x plus 5. Now that's what my y sub 1 is. And then in the next column over, I'm going to go ahead and write negative 2x minus 4. That's what my y sub 2 is. Okay? So to be clear, here's y1, here's y2. Now I'm going to give a shout out from my first period class to somebody. Somebody in my first period class knew what was up. What we're looking for when we go to solve one of these to find the solution is that we want the y values in columns 2 and 3 to be the same. Does that make sense? So that's going to kind of give us our solution. So we got to find a pair of y values that are the same, and then that's going to help give us our solution. So shout out to Maestro for my first period class for making that observation. Maestro's Christian Spore. All right, so for the x's, I've got to pick them. You know what they say about picking things, don't you? You can pick your friends, and you can pick your nose, but you can't pick your friend's nose. Don't try it either. It's not worth it. Okay, negative 3, negative 2, negative 1, 0, 1, 2, and 3. That's how I roll. That's how I pick my x's in a table. That's usually how I roll. Hopefully my algebra skills are up to par today. If I plug in a negative 3 into y1, that's going to be negative 3 plus 5. Negative 3 plus 5 is going to give me 2. If I plug in a negative 2, that's negative 2 plus 5, and that's going to give me 3. And if I plug in a negative 1, it's negative 1 plus 5, and that's going to give me 4. The rest of that column reminds me of dancing. You know how many dancers it takes to screw in a light bulb? 5, 6, 7, 8. Okay. All right. The last column, it's kind of tricky. If I plug in a negative 3, I'm going to have negative 2 times negative 3. That's 6. 6 minus 4, that's going to give me... Dude, really? Do I even need to go any further? We said we were looking for columns 2 and 3 to have the same y value. Maybe, just to be safe, we better do this one more time. If I plug in a negative 2, that's going to be 4 minus 4, and that's 0. And then negative 1 would give me positive 2 minus 4, so that's negative 2. And then a 0 would be negative 4. And then that's going down by 2, so that's negative 6, negative 8, and negative 10, right? So, yeah, we got our answer. So what is our answer? Our solution? Our answer is what? Negative 3, comma, 2, right? XY, ordered pair. Well, that was easy. That was cool. That was nice. That was like a cool breeze on a hot day. That was like paying for a double cheeseburger at McDonald's and then putting 3 patties with 3 slices of cheese on it. That's very rare. I'm kind of bummed out by the McDouble. 2 patties and 1 piece of cheese. Come on, really? You can't put that second piece of cheese on there? Really, McDonald's? All right. There are some skills, and I'm going to spell it this way, not to be confused with Skittles. There's a YouTube video going around with a guy with a foreign accent. Anybody see that one? I got some Skittles. Sounds like he's saying Skittles. But some skills, there's some skills that you need to have. One of which is can you graph a slope intercept equation? Do you have that skill in your back pocket? Are you capable of doing that? You need to be. Graphing a slope intercept equation, something like y equals 3/5 x minus 2. Can you graph something like that? Are you capable of doing that? If you're not, well, then you're going to struggle with what we're doing today. So, I'll get my graph paper out here. That's not my sound-making graph paper. That's just the regular graph paper. Yeah, the sound hasn't been coming out so good in the video, so... So where should I start when I graph this? I'm hearing a y, I'm hearing the negative 2. Yeah, this negative 2 here, that's my y-intercept, and that's the first thing I want to look at. And that's where I want to start with the graph. So I start with my y-intercept. So that's the point 0, negative 2. 0, negative 2. So on my y-axis, I go down to not negative 1, but negative 2. So I go ahead and plot that point. And then after that, I'm going to look at the rise over run, the slope, or the sloppy as I like to call it. 3/5, that's rise over run. That's 3/5, so that's my slope. So from the point that I plotted, I can go up 1, 2, 3. So up 3, and then what? Over 5. Which way? To the right or to the left? To the right in this case. 1, 2, 3, 14, 5. I don't understand Bono, but whatever. Okay, so there's my second point. Now, suppose I didn't have enough room on my graph to go up and over 5 to the right. Could I go down 3 and 5 to the left? Would that be all right? Why not? And a lot of people don't think to do that sometimes, so that's negative 3 over negative 5 is the same thing. So I could go down 1, 2, 3, and 1, 2, 3, 4, 5. So if I do that, these points, when I sketch my line through them, should go through all of those, if all is well. If all is well, my point that I sketched should go through all those points, and I think it does. Okay. How's everybody feeling about being able to graph slope intercept? We good with that? Good. All right. Well, another skill that you need to have is to be able to put an equation from standard form to slope intercept. To be able to write an equation from standard form to slope intercept. You really need to have that skill, and that's something that we kind of skipped over in chapter 1, section 4 or 5 or 6, converting equations from one form to the next. Suppose we had something like 3x minus 8y, and that was equal to something like 24, let's say. So putting that equation into slope-intercept form is useful because sometimes we don't know how to graph one of those, or sometimes we just want to find the slope of that. Right, meow. And I did say meow. Sometimes we want to find the slope of that quickly. Oh man, our algebra sometimes is a little weak. I'm trying to put that in slope-intercept form, so I want the y all by itself, eh? So I reckon I probably ought to take this 3x term here and do what with it? Subtract it, or I like to say put it on this side of the equation, right? So when I do that, I'm going to have the negative 8y still where it is, and that 3x is going to change SIGNS signs. It's going to be negative 3x, and that 24 has a plus, a coefficient of +1 to it. So we've got that. Now what should I do? Divide. And when I divide, I got to be careful. I divide this by negative 8, this by negative 8, this by negative 8. I like to split it up like that just to be sure, just to be clear when I reduce my fractions down if necessary, what happens. So then the 8's cancel and I'm left with y on the left. That's what I wanted. Now what happens with that negative 3x over negative 8? Keep it like that? We could. But if you're asked to simplify it, the negatives are going to cancel, right? So 3/8 x, 3/8. Where should I put the x? Does it matter where I put it? Yeah, I remember from a couple weeks ago, we said the x has got to be real distinct. It can't be down at the bottom. It can go up top or on the side. But so 3/8 x, and then what? And then -3. Awesome sauce. Awesome sauce. So that's a skill that you're going to need to be able to do over and over and over again in these exercises tonight. We feel all right about that? Good. Okay, the last skill, I tried to leave enough room for 3 things, but maybe I didn't. The last skill is going to be to graph a standard form equation. To graph a standard form equation. Now this is one that reminds me of makeup. Reminds me of makeup. So suppose we had something like 30x minus 60y equals 120. Now I know what you're thinking. You're thinking, dude, our graph paper only goes from -10 to 10. There's no way this is going to fit. Well, dude, yeah, it is going to fit. Watch. Watch. I said this reminds me of makeup. I use a technique that no other book has ever mentioned. I don't know why they don't. It's nothing special. All it is dealing with intercepts. If you understand what an x and a y intercept are, this technique will make perfect sense. Let's think about an x-intercept. An x-intercept is the value of x when? It's the value of x when? Whenever y equals 0. So what I like to do is I like to go to Ulta with my wife and then complain about how much she spends in there. Because one trip to Ulta, she buys 3 things. That's $150. True story. So anyway, there's a reason that I got this big dot out here. Because what I'm going to do is I'm going to use a technique I call the cover-up method. You'll never see it in a book. I call it the cover-up method. So check this out. The value of x when y is 0. When y is 0, guess what happens? I replace this with a 0, which means this whole term goes away. Right? So 30x is equal to 120, so that makes it easier to find my x-intercept. What is it? My x-intercept ends up being 4. Awesome sauce. So my x-intercept is 4, and I've got the point 40. We feeling all right? Similarly, and we could go ahead and plot that. 1, 2, 3, 4 on the x-axis, right? There's my x-intercept, 40. Using a similar technique, we could find our y-intercept. Our y-intercept, remember, is the value of y whenever x is 0. So this term is going to get replaced with a 0. That term goes away. So what's my y-intercept? Watch your signs. Y-intercept is -2. So I plot that point. How many points do we need to plot a line? Just 2. That's it. We got our 2 points. We can go ahead and plot the line, graph the line through those 2 points. Once we have the line through those 2 points, is it kind of easy to find the slope to it? I think so. I think so. Well, we went up 1 and over 2. Up 1 and over 2. So our slope would be a half, right? We feeling all right? Okay, so those are skills that you're going to need to use. And all we've got to do now is look at a few more examples, and I think we've got it. I think we've got it. Ready? Good. So let's go back to that first one. And let's do it again. This time, let's solve by graphing. The same one that we use tables with, so solve by graphing. So this is the same one we used the first time, but first time we used tables. This time we're going to use graphing. X plus 5 and negative 2x minus 4. So I really like this solving by graphing technique when they work out nice. I like it when they work out nice. We got a question. Oh, why do my y's not have a y1 and y2? Good question. I could put one on. A lot of times, most textbooks won't put them. Okay, so it's one of those optional things. In the last one, I just did that to distinguish between the 2 columns. That one of them was my y value for the first equation, and the other was for the second. Really good question. Yeah, keep in mind most books aren't going to put subscripts on them. Okay. Okay. So when we go to graph that first one, where should we start? The 5 on what axis? On the y-axis. So my y-intercept is 5. 1, 2, 3, 4, 5. So there we go. There's our y-intercept. And then what? This is kind of tricky sometimes. A lot of people mess up the slope on this one. Remember, the slope is given by the coefficient of x. Well, x doesn't have a coefficient, so the slope is 0. No, it's 1. So that means we go up 1 and over 1. Now, what I like to do when I graph these, when I solve by graphing, is I like to put as many dots as I could fit on my graph paper. Okay? And the reason I do that is I think it makes it more clear what the solution is. Here's what some people do, and I'm guilty of this. Some people, when they sketch their line, they do that, and they say, that's good enough. No, it's not. No, it's not. Watch what happens if we keep doing those dots. The dot goes here, the dot goes here, and here, and here, and here, and here, and here, and here. Do you see how far off I am by the time I get to the edge of the graph? So I like to make as many dots as I can fit on my graph, Okay? In hopes that when I graph the other equation, that I'll see the dots that meet in the same place, right? Okay, so on the other one, where am I going to start? Negative 4. 1, 2, 3, 4. So I start at the negative 4, and then what? Rise over run. So I could go down 2 and over 1. Okay? So I go down 2 and over 1. Down 2 and over 1. So I go ahead and sketch my line, and I'm a lousy line sketcher. So I got that. Dude, that doesn't even hit any of the points. That's horrible. That's awful. Don't do that. Okay. Maybe I should just keep rising and running. Up 2 and over 1. I said up 2 and over 1. I don't know why my pencil's not working. Up 2 and over 1, up 2 and over 1, up 2. Oh! There it is. What's our solution? Negative 3, 2. And we saw that from the table method, right? Awesome. Any questions so far about solving by graphing or solving with the table method? This whole section we're solving by graphing. On Wednesday we're going to solve with algebra methods. That's going to be fun. So there's one final bit of writing that we need to talk about, and that's classifying systems. I'm going to use some cursive. Classifying systems. Whoop. Systems. My cursive S's look like ampersands to me. I don't know why. Classifying systems. Here we go. So there's basically two, but there's three. There's three categories. Systems are either called consistent, I can spell, consistent, there we go. So systems are either consistent. All that means is that they have a solution. They have a solution, okay? They have at least one solution. It means they have at least one solution, okay? Within this classification, sometimes they're called, they being the systems, sometimes they're called independent, which means just one solution. It means they just have one solution. When you graph the lines, they will intersect one time and one time only. The other case is where we have a line and then we get another line, and those lines, when they meet, they're in fact the same line. And what we call those, as you might be able to guess, would be dependent. Dependent. So the deal with dependent systems is they have many solutions. And in Algebra 1, that was good enough to say that they have many solutions. Okay? In Algebra 2, we're going to take that a step further, and we're going to write up the answer as this. We're going to write up the answer as all the points that are on the line. I know it's kind of weird. I know this is probably something you've never seen in a million years. But what that says, that brace, xy in parentheses, that weird vertical line, and then ax plus by equals c. What that's saying is the solutions are all the points on the line. The equations that are given might be in a different form, but they are going to be the same equation. Okay. So I said there's two, but there's three classifications. So consistent means there's a solution. Independent means there's one. Dependent means there's a bunch. Well, what's the other case then? You might be able to guess. If one of them is consistent, then the other one is inconsistent. Inconsistent. So consistent means there is a solution. So inconsistent means there's no solution. It means the lines don't meet. Well, if the lines don't meet, what kind of lines are we dealing with? Parallel lines, yeah, sure. So in this case, we're dealing with parallel lines. And what is it that we know about parallel lines? Their slopes are what? What's true? The slopes are the same, right? So it's kind of easy to get confused when we talk about systems where we have parallel lines or systems where we have the same line. You'll see what I mean in the next example. Okay. We ready to do this? Good. Here we go. Couple more examples and then we're done. Two more examples. That's it. Example, solve by graphing. Solve by graphing. Y equals x plus 6. 2x minus 2y equals 4. Love this one. Reminds me of Christmas. Christmas is probably one of my least favorite holidays. Why? I don't know. I just don't like how commercialized Christmas has become. Like the Black Friday shopping and everything. I go Black Friday shopping and I appreciate a good deal, but I just don't like how commercialized it is. I think it's just too crazy. But anyway. So our first equation, where should I start with graphing that? The 6 on the y-axis. 1, 2, 3, 4, 5, 6. So we plot that point. Up 1 and over 1 because of the slope. Up 1 and over 1. So remember on this graph paper, let's keep on doing that. Get as many dots as we can on the paper. And then maybe I'll take this line and I'll sketch it. So I'll take that line, connect up my dots, have something like that. I think that's pretty okay. Not too bad. So then the other one, what should I use to graph this other one? Should I take a trip to Alta and get my $39 cover-up? Okay, so my x-intercept is 2, and my y-intercept is -2. And I can kind of see what the slope is from here, can't I? Down 2 and over 2 more, down 2. Dude, if I'm going down 2 and over 2, then I'm going up 1 and over 1. So, but I went up 1 and over 1 the last time. So they're parallel. So what's the dealio? It's, if we classified it, the classification is it's inconsistent. Inconsistent, but we were asked to solve it. You're right, it is inconsistent if we were asked to classify. Solve by graphing, what do we say the solution is? We could go to the west side and say what they say over there. The solution is they ain't one. They ain't one. I like to write that. They ain't one. Or we could just say NS or no solution. Whatever we want. But I like using my west side accent sometimes. They ain't one. What's the solution? They ain't one. How we feeling about that one? Got it? We're almost done. Almost done. One more. Uno más. This next one's kind of tricky. Kind of sneaky. Last one. Example solved by graphing. 2x minus 3y is 6, and negative 2x plus 3y is negative 6. Now, the better you are at algebra, the easier it's going to be for some of you to spot some of these and what ends up happening. But maybe we want more practice on that cover-up method. Maybe we want more practice on that cover-up method, so let's try that. So, for my blue equation, what's my x-intercept? My x-intercept is 3. And what's my y-intercept for the blue one? My y-intercept for the blue one would be -2, right? Okay, let's go to the red one. What's my x-intercept for the red one? I'll slow your roll. The x-intercept for the red one's going to be 3. And what about the y-intercept for the red one? Dude, they go through the same points. What do we say? In Algebra 1, we would have said there's many solutions, and that's good enough in Algebra 1. But the deal is our solution set is this. Our solution set is the set of all ordered pairs x's and y's such that they are points on that line given by that equation. So that's just saying the solution is all points on that line. So if I went ahead and sketched the line that goes through those 2 points, my solutions are every single point on that line. And there's a bunch of them. There's a lot more than just the 2. There's a bunch of them. So that's it. It's been real. It's been fun. If we had to classify that, that would be classified as a dependent consistent system. Everybody feeling it? I'd like to give a shout out to my second period class. They were awesome today. I'd like to give a shout out to the future Mr. Minnick. He's probably in the back of the room taking notes. I'd like to thank Mr. Minnick for not telling too many corny jokes. And I hope everybody has an awesome rest of the week. Thanks. See you next time.
Good.